Okay, good morning, everyone. Today we have another hands-on experiences, so we try to see how to work those concepts that we're learning for predictive analytics using KNIME environment. Having said that, when you open KNIME, sometimes it asks you to check for updates. Just let it go. I mean, basically, you don't have to do that much of thing. You just need to say like next, okay, next, and it goes as it is. Like here, as you see, asking for updates, and then I click yes. On top of that, you might remember the last week we talked about different nodes or modules that you may need in your project. Based on your specific project, you may need to use some nodes that I haven't talked about. Here I'm talking about a very easy one. For example, I want to import a CSV file to KNIME. In this case, you might remember that I told you can easily go and search it. But sometimes, let's say that we are talking about a certain node that is not existed in your basically repository. For those cases, like here, just Google, like here I want to read CSV node, which using in the KNIME. These are just some keywords. So having said that, I come to Google, paste. Usually those nodes are in KNIME Hub. So click. You can find a description, and but for getting them into KNIME, you go to this icon. So if you, as you see, when I take my mouse near this icon, the shape changed. Just grab, drag, bring it to KNIME, and leave your mouse. Sorry. As you see, now I have a CSV reader module. On top of that, I've talked about R and Python, and I know some of you took those courses before. So if you're interested to do some part of your project with R and KNIME, there is similar modules. As you see here in this slide, one of the modules is R and the one is Python. So you can Google like Python in KNIME, and you find the module and you drag and drop into KNIME. But for Python, R, or other modules, sometimes you need to do further installation. For example, you also need to install a KNIME Python kernel. But when you drag and drop the mouse, drag and drop the icon, it just automatically tries to install. Therefore, from now, even if you, let's say you want to use neural network, decision tree, SVM, or other machine learning algorithm, if they are not available in your KNIME, when you search in the KNIME repository here, you can easily Google it and just drag and drop, and you can have the node ready for use. On top of that, for some cases like Python, R, or some more advanced nodes, you need to install some kernels. So it just, all of them happens automatically, so you don't need to worry about that. Any questions so far? Okay, I think it's very straightforward. So the good thing about KNIME is easy to use. So doing such a thing, using different nodes, you just need to Google and find the associated node, come to here, drag the node that you need, and just use it. Okay, so let's do two experiments. like go to your model under big file, just import, download everything. So I give you like a few minutes to reach your model, to log into your model and download these workflows and also these CSV files. I already downloaded, but I expect you just want to do that. So take your time, no worries. I give you like a few minutes to do all of it. Hopefully by now all of you downloaded the files. So go to the statistical outlier detection. Just click on it. And if you go to your KNIME, you can see it's all automatically loaded into KNIME. You can just click here, save as, and just save it on your one of your folders or in the KNIME environment. So look at my left side. It wants to save locally. So I press OK. And that's it. So as you see, now I have some gray icons. These are some components that aggregates your nodes. So if you click on it, you can see inside this component, I just have one node, which is CSV reader. But how to make that? So let me just drag and drop some of them. So let's say I go to read, I have CSV read. Then let's say I take a filter, color filter, and then maybe just a right. So right. It's not our project, but just an example. Now I want to make first two nodes in the one component. So I just select these two by my mouse, right click. You can either create a component or meta node. So let's click on meta node and let's just name it meta node 1. When I click it, it would be expanded. So as you see, instead of 2 nodes, both of them are merged in the one meta node. So when I double click, I can get inside it. You can just get it back. So again, right click, go to meta node and click on expand. It will return to the its initial shape. So let's make a component. So I select these two, right click, create component, and just component. Let's name it component 1. Now, when you click it, you cannot get into the component, but for meta node, like read data in here, when I click on it, I get to inside my basically meta node. So basically here I have 2 meta nodes. Components, it's not that much useful because you don't see what's inside of it. So let me just right click, go to the component, expand, and return it back. So you might ask me why we have component and meta nodes. The only reason, sometimes for your project, you might have several nodes and your page might be very busy and very ugly, crowded. So what can you do? You can grab some of them that have similar functionality and put them in the meta node or as a component. Any questions so far? Okay, I guess there is no question. So let me just delete these. So if you click on read data, you get inside the meta node. For read the CSV reader, just double click. You see there is a browse icon here. You need to browse the location of file on your system. So for this one, just find airline.csv, select and press open. You can leave the remaining as default. Press OK. So now let me close this page because I want to go to the main one. So now I import the CSV table, and I have another meta node, pre-proc, or it stands for pre-processing. Double click. As you see, the input divided in 2 different branches. First of all, for your project, probably you don't have to do these things. These are just for teaching purposes, and maybe some of them looks extra, so you don't have to do all of them. I just wanted to show you different nodes in a case scenario. So it's the reason I put some nodes that may or may not make sense for your project. So in the lower branch, I have a comment filter. If you click on it, as you see, I selected 3 variables to be included, and I want to exclude the remaining. Okay. And then I group them by city destiny, latitude and longitude. Basically, for different city destination, I might have different airports. This latitude and longitude is just for different airports. So if you click on it and execute it, so right click and execute. Then if you right click and group table, so as you see for some city destinations, so let me just check, sort them. It seems they're unique, but anyway, if you see multiple cities, it just means in one city there is 2 airports, or we use 2 different airports in one city. Okay, but that's what happens in the upper branch. If you click on column filter, as you see now, I just filter out only 3 variables of city destination, air delay, and airport name. Press OK. So let's see what I do with the missing values. I think this note here is might be important for your project. So as you see, for string node, it has 2 sections. The upper section is for string, or sorry, my voice doesn't help today. So one is for a categorical variable or string, and another one for numerical variables. As you see, I said if it's a string, use a fixed value and impute unknown. So what I do here, I just say if there's a missing value in the categorical variable, which here they call it a string, don't drop those observation, and instead for them just impute unknown. As you see, we have one option which is remove the row. So whenever there is a missing value, you can remove the row, but I avoid that option. Can anyone tell me, okay, also for numerical variable, also I can remove the row. But again, here I said no, impute with median. So can anyone tell me why I didn't use removing the row? Because for both type of variables, I could simply just remove them.
Because there are lesser number of records, maybe, to analyze.
Yeah, outcome wise. What about outcome wise? What happens if I drop like a significant portion of my data?
We won't have enough to train enough records to train the model.
That's very good, and it could be a reason for having a bias, in your prediction. So you might remember that we talked about bias, and one could be just dropping so many observations. Let's say here is the airport, but let's say for credit card, and if for certain variables, female respondent don't respond those some questions, and you just want to drop the associated rows, maybe you lose too much observation for the female credit application. So it might be one of the reasons that your model couldn't be trained very well for female, or other cases. And same for numerical values. So you can, it's a good practice to avoid dropping the rows, unless, let's say, more than 95% empty, those rare cases. But generally speaking, imputation is much better than dropping. And I don't recommend to drop rows or columns in your project. Later, I teach you how to work with a string variable here, because for machine learning, you cannot use a string variables or categorical or variables or in categories. You need to convert those variables to as a numerical equivalents. So next week you learn how to work with those kind of variables. Even we can use text document. Text is not numeric, but we can find equivalent numerics and just use them for our project. Click OK. Also, I have another note, constant variable column filter. What it does for the columns, which are basically the variables. So if they just have unique value for whole observation, we just want to get rid of them because they are not useful for prediction. And it might take some time or memory from your system to work with the variables that doesn't contribute. So it's the reason we want to filter them out. And again, here I use city, destination, and airport name for grouping them. If you execute, then right click and group table. So, okay, I think I forgot one of them. So for group, let me go to configuration again. And as you see, for categorical variables, like city, destination, airport name, you can group them, but you also can have aggregation. So summarize aggregating your numerical values, which I did in manual aggregation. So for a delay, I just said find the mean of those groups. For example, if for a city destination, there is 2 different airports, and one of them has delay of 1 hour, another one 5 hour. So when we group city and airport names, one delay was 1, another one 5. 1 plus 5, 6, divided by 2, 3. So we get the minimum of all the delays that get to a certain airport and certain city. Any question about aggregation? How it works? Again, let's say I'm talking about Boston Airport, Logan, Boston, and JFK, New York. Each of them has 3, let's say 3 flights, 3 incoming flights. And when you group them, for all of those 3, since the city, destination, and airport name are same, you just see one observation or one row when you group them. Because our group components are just city name and airport destination. So what happens to those 3 incoming flights? The only way that we can show them by aggregation. So I'm just saying that aggregate day delay and divide by total number of delays, or just find the mean of all flights. You press OK. So now again, I have another group that has city, destination, airport name with the mean of all incoming flights, or which has delay of all of them. So again, if you look at here, we have a city, destination, and also if you look at this group, we also have another city, destination. These 2 columns are same, so you can join them based on the common column, which is city, destination each. Let's look at the joiner. So if you join, so you city, destination, airport name, mean of air delay, longitude and latitude. So longitude and latitude are coming from lower branch. From upper branch, we have air delay, airport name, and also city, destination. Again, there is not that much of reason for doing such a thing. These are some practicing, knowing how to work with group by, missing value, filtering, those kind of things. So don't worry if you get confused here, because you might say more than half of it is extra. I know it's just some practice.
Professor, I have a question.
Sure.
Hi. So, okay, this is the pre-processing, right? Is it like this, like the standard filters that are applicable for other files as well? Or are they like, it just happens, or like, you just have to assess which are the ones that you have to use?
Actually, this is just a sample workflow. What I assume, but no worries. In next classes, we go to more advanced one, but I didn't want to show you a really advanced from real project to make you confused for today. But in next classes, you see much more useful ones. But what I assume, common filter might be very useful for most of projects. Missing value is very useful. Constant column filter is very useful to this. I assume these three should be useful for most of projects.
Okay. Okay. Thank you.
But again, we go over KNIMEs and more workflows, because I don't want you guys go and study these nodes one by one and spend a lot of time and don't get the bigger picture. For avoiding that, you'll basically in analytics part of the course, most of your learning is just happens by working with the actual workflows. Otherwise, so for example, as you might remember in the previous class, I said, click on one of the modules, click on question mark, and you see so much of documentation. But it's not a good way of learning these things because it might take forever. And you might forget easily. So I just want you guys basically learn by doing things instead of just memorizing what is the joiner like module and what it does. The other useful one is numeric outliers node. As you see here, let me just open it. I'm just focusing on mean air delay. This is my numerical value. Latitude, longitude doesn't make sense to do outlier thing. So one thing that I put here is 1.5. I think is the default value. So you find, if you forget the basically how to exclude outliers statistically, just Google outliers and you can easily find that. But basically, I'm just saying that everything over 1.5 quarter from mean, either side, either 1.5 more than mean or 1.5 times IQR, which is interquartile range multiplied interquartile range. So anything more or less than that are outlier and should be excluded. So don't pay attention to this bottom part. This is like just saying that it want to estimate population from a sample. So there's different methods, but no worry, just keep it as default. What can you do, which is more important for your project? First of all, thinking about the coefficient of IQR for your outlier, or you can just leave it as default. But the more important, the most important, just saying that how you want to work with the outliers. Like here, I just said apply to all variables, not just lower or upper bound, or all outliers. And also, I'm just saying that remove outlier rows. But as you see, you can, these two doesn't make sense that much, non-outlier rows or replace outlier values. So you want to get rid of outliers. So again, this could be one module that's important for your project. Just select, remove the outlier rows and work on all of the outliers. Click, okay. So when you exclude it, you can see these are the values that don't have any outlier and are good for your project. So again, excluding outlier doesn't necessarily improve your project. Just as you might remember, Christian, which is a standard data mining project, has a cycle. So you go through the cycle back and forth. For example, you build your model, you do evaluation, and just look at the prediction accuracy. If you're not happy, maybe you can go back and change some parts. One of the changes may be just considering this node for excluding your outliers. Any questions? So I give you 1 or 2 minutes to play with this workflow. Maybe you can go just do multiple things. For example, here, right click, meta node, expand. So look at now, it's much more crowded. Or you can do expand again. Anyway, I give you like 1 or 2 minutes to play with that, and just maybe again you can, instead of this all of them, you can select these 3 and let's say create meta node, and maybe I name it data prep 1. Also, you might see there is some nodes here. For creating them, just right click, new workflow annotation. Maybe here I can say data preparation practice. If you, after creating, you can go here, click on the double click and just change the colors. Like for example, brown, whatever, or any colors that you are more interested. So you select, go to this button, go to top left, and you can change the color. Again, look at here, when I take my mouse on this annotation, on the left side, you see there's a pencil, double click, and you can change the color. You can take your annotations anywhere. Just make it larger or smaller. Actually, this is a good practice, especially if you are doing a group project. So your friends might be confused with so many nodes in your project. You can make meta nodes or you can make annotations. So your group mates can easily understand what is going on and they can follow the process. Okay, so just set this one. So, okay, you might remember we talked about cross-validation. So in cross-validation, you divide your data into equal sections. Let's say I want to do 5-fold cross-validation. So what I do, I divide my data into 5 sections. 3. Let's just name section 1, 2, 3, 4, 5. So each time I use 1-fold for 4-fold for training and 1-fold for validation or testing. So having said that, let's say first time, let's say train, validate. For the first time, fold 1, sorry, not Fold 1 should be here. Fold 1 is here for validation. Fold 2, 3, 4, and 5 for training my model. Next time, I used fold 2 for validating, and the remaining folds for testing. Sorry, for training. And same up to the last fold. So I used fold 1 to 4 for training. And fold 5 for testing. Then I look at the overall accuracy in all the folds. First of all, we want to have similar accuracy in all of them. Like if one of them is 80%, the other one is 60, the other one maybe 95, it just means you train too much. You overtrain your model. Maybe one reason could be you have too many variables. In some cases, when you have too many variables, your model might be trained very well in one part of your data, but not for all the parts. Or maybe your data is not very balanced. Let's say you want to predict survival of Titanic, and let's say from 100 cases, just 3 survived, or not 3, maybe let's say 10 of them survived, and 91 of them didn't survive. So in that case, maybe your model wouldn't train very well on all the cases because it's highly imbalanced. So it's and it just could have several reasons. Anyway, we don't like such a high variations. Maybe if you have 75, 74, 76, is much better than 80, 60, 95. Just means your model is reliable, and later you can your reliability is so high that you can generalize your model for future use, because like changing the accuracy is just within 1% versus here in some cases like between like 20 to 30%. So we like this model more. Any questions? Hopefully they are straightforward, but no worries. If you have any questions, you can just later reach me during my office hours, or like just email me, and maybe we can find a time for a meeting so we can go deeper in your proper time. We also, just as a reminder, in the easiest way or more traditional way, we just have one test and one train and one validation. Let's say train 70%, validation or test 30%. And in your Titanic assignment, you can just divide your data randomly in 2 sections and do prediction. That's enough. But for your project, please do cross-validation. And I think that is a better approach for a project, not for your assignment. Okay, so if there is no question, let's just go to the second line. Let me just disconnect from here. Okay, there's a question. What is the purpose of method? Okay, there is a question. Sorry, I just saw a question. I'm not sure if it's an old one. One of your friends asked, what is the purpose of metronome? It just for...
I asked that question before you answered. I mean, I'm sorry.
You got the
already
point?
answered. Yeah, I got the point. Yeah.
Okay, that's
Yeah.
good.
Thank you.
So go to, what is that? Let me share my screen. Okay, so just double click on cross validation underline SVM. It just automatically would bring into your KNIME workflow. As you see, I have another meta node just for making it looks better. And also it's very helpful. Let's say I said that for your funnel project, I expect you to do 3 ways, to do your project in 3 different approaches. And the reason just for trying to improve your accuracy. Let's say one time you do with SVM, another one you do with decision tree, another one neural network. So anytime you can just make a meta node for what you did, so you can makes your life easier when you do a group project. Okay, having said that, okay, I have one old. Okay, so by the way, I created this one last year. So and I updated my KNIME. So some of your notes might be deprecated. So let me see if there is. I have a newer version. This quarter. Let's see if this one. Yeah. Anyway, later I show it to you. But double click on CSV reader and just go to browse. On your system, find cars.csv and just open it. As you see, it seems an unknown table, which is not really good for your project. So just let's say you should rename all of the columns in the way that all of them make sense. We try to predict the last column, which is a car brand or car types, based on the other information that we have in other columns. Press OK, right click, execute. Then double click on cross validation node. So what does this node do? It just try to makes 5 folds, and each time use 4 folds for training, 1 fold for validating or testing your results. As you see in X partitioner, when you double click, just a number of validation in 5, it means that it does 5-fold cross validation. And class column is column 18. The column, let me just go back here. Column 18 just has the car brands, the last one that you want to predict. So what it does, when it divides into 5 folds, it tries to be balance column 18. So for example, one category of car is van, another one bus. We want to have all of the categories on each fold. For example, if one fold doesn't have car, or so it doesn't have van or bus, when you train the model, it doesn't predict well. So for that reason, we want to balance out column 18 over all the folds. And in each fold, we want to have all the categories of column 18. Also, there is a seed number. Basically, there is a the inside of each machine learning algorithm, there is a probabilistic component. So anytime that you run this model, you might get a slightly different result. So for avoiding that, you can assign a random seed. Let's say you can keep the default one, but I press 1, 2, 3. So later on, whenever I run this model, I get the same result. So again, what you need to have, 5-fold cross-validation is stratified over column 18. It just means for each of those 5 folds, we want to have all the categories of column 18. Leave one out is another approach of machine learning. I just maybe later explain to you, but for now, just 5-fold column 18 and random seed 1, 2, 3. That's okay. Execute. So this node has 2 sections. One section for training, just and another section for validating. So the upper section goes to SVM learner. SVM learner is just a machine learning algorithm. So SVM is one of the most common algorithms. If you click on it, you don't have to do any changes except for class column. So you need to specify which column you want to predict. Press OK. So SVM predictor, what it does, it takes the trained model from SVM learner and also get the validation set from X partitioner. And also here, I just said when you do prediction, the name of the predicted data is prediction column 18, and it's an arbitrary name. You can just change it to any name that you like, and also append it to my current data table. Right click, execute. Then we just want to aggregate all the results from the tables. In the X aggregator, you just need to specify your target column and prediction column. So prediction column is the one that we already named here. And also the target column is the basically actual column that we wanted to predict. Execute. Now it might take more time because now instead of one training and one prediction, you just do train and prediction 5 times. Let me go here. Okay, so for first column 18, second one, the predicted one. Press OK. And it's same for this one. So you can keep it or just import the updated version. So right click, execute. So then right click. You can get the confusion matrix. So actual one versus predicted ones, or also you can check the accuracy. 75.4 or 70, almost 75%. Okay, so we had 4 categories of car: van, sub, bus, and Opel. Sorry, my voice doesn't help today. So, and the prediction accuracy is 75%. Just based on your intuition, do you think is it a good prediction or is it bad? Is the accuracy is good or does it's terrible? Can anyone have an idea?
I think it's good. I think it's
And
good.
what's the reason for it?
I don't know. I read it somewhere that a prediction level of 75% in certain industry way, it's pretty good prediction number. That's what I remember.
Okay. There is, I mean, some general ideas, and let me tell you. So one idea could be, one of the major ideas is actually when you are trying to predict some healthcare related outcomes or something related to humans, your accuracy is much less than you try to predict some mechanical things. Or like here, we are trying to do some mechanic. So the car type, which is van, sub, bus, and Opel, these are mechanical things. So for human-related things like survival of a patient, maybe 75 looks really good. But for mechanical target values, maybe it doesn't seem great. But just let me show you something. Let me stop here. And so our dependent variable was van, so it was car type. It had 4 categories of van, sub, bus, and Opel, right? Let's say I don't use any machine learning algorithm. I just, for my column 18, I just randomly pick a name. What would be my average chance? What is my chance of predicting correctly?
25%.
Yeah. So if I don't use any algorithm, if I don't spend a lot of time, I have 1 out of 4 or 25% chance of guessing correctly. So I train my model, and this model has near 75% accuracy. So almost 3 times more than random chance. So it doesn't seem too bad. But let's say I just have 2 categories of van and let's say bus. And my accuracy is 75%. Since it's just in this case, I have 2 categories. The random, if I just pick the categories by chance, my chance is 1 out of 2 or 50%. Although there is some improvements, but it's not as impressive as first one, which is this 3 times improvement. Also is a mechanical kind of object. So I'm less happy with 75% here than here. But let's say, for example, I've looked at the papers, research paper about heart transplantation survival prediction. So for that case, for patient survival, my dependent variable or target variable just has 2 categories of survive and death. So random chance is 50%. But if you look at some papers regarding the heart transplantation, in heart transplant, I saw the best accuracy was near 70%. Here, there is not that much of improvement from random chats, but it's related to humans. So humans are very complex. So 70% here is not too bad. Maybe it's actually good ones, versus in the earlier version here doesn't seem too good. But again, here for the first one, you can say 75% means 3 times improvement in random chance. So it seems to be a good option there, a good like outcome there. Any questions? Okay, so I need you guys to have such a justification for your final project. As you see, machine learning is not scary. You don't have to know too much from what those algorithms means, what's the mathematics behind of that. Even if you look at here, what is this? Okay. Here, you don't know how SVM works. Actually, it has a very complex algorithm, or the mathematics behind it is even for regression. Frankly speaking, I think regression is more difficult than SVM, but you don't deal with the mathematical underhood, the mathematics underhood. So you just simply drag and drop the node, the component, and the only thing that you need to do, just identify what is your dependent variable in class column. So please don't be scared from machine learning algorithms. Even in Python or R that your friends do scripting, those scripts, they do something similar, but without visualization. So without such a graphical interface, they just type it. So when you do programming in Python and R, you definitely have a lot more flexibility. But the general process is like this. So instead of drag and drop a rectangle with some visual components, you just type the SVM model, something like that. Again, as I said, you can do Python and R programming inside your KNIME if you're comfortable with it. You just basically need to just Google R script or Python script in KNIME, and you need to basically drag and drop Python or R component. And after some installation, you can just have those codes as a component. So let me just find one of them. Okay, look at Python script here. Here you can just put your script like print hello, hi, whatever. You can do all the scripts here that you have some certain input variables and output variables, and you can just use it for your project. But again, KNIME is more than enough. If you have some interest to do Python R, you can just simply drag and drop the module and just put your codes inside the script. But the goal of this course is not teaching scripting in Python scripting or R scripting. So you can, if you already learn, you can use them to help you for your project. Okay, next week we have a quiz. So I put the information on your basically PowerPoint, and hopefully it shouldn't be difficult. It should be as easy as before. And also, as you might know, we just hired a TA, so hopefully your grading is much more faster. This time it was the standard. So it's COVID time. Finding a good TA takes time. So, but hopefully from next week you get your grades much faster, and we can have the feedbacks on. Okay, so I expect you have some questions. Is the reason, I mean, you didn't ask too much, so we have some extra time. But anyway, that's for today. Is there any questions?
The quiz, is it going to be like the same format like it was last week where you just open it up and we have until like tomorrow to complete it?
Yes, it's just it's like an assignment. It's an assignment quiz because the course is online and you are at home, so you just have time. At the time you get the questions, you have like 1 day to respond it, and then you upload your answers.
Okay. And is anything going to be like, we have to do something like on KNIME or anything, or is it just like multiple choice?
I haven't decided yet, but since you said, let me think about that. But
Yeah, that's crazy.
KNIME might be one of the questions. I haven't decided to include KNIME, but maybe.
Oh God. Okay.
Come on, Gabriel.
It's my bad. I didn't think I'd walk into that.
Oh, no worries. So no worries. This time I don't include KNIME.
Professor, I also have to ask. Okay. Actually, I was doing along with you this KNIME thing. At the scorer here, I get this exclamation yellow mark, which is, I guess, is not working. So somewhere I've done something.
It just means my name is updated, but this file is old one. So you can run it, execute, and it just works.
It is the other one, the below one. I'm getting the error on that part.
When you click on it, first column should be column 18. The second should be prediction 18. Prediction column.
Prediction 18. Okay, gotcha.
But I update this file. So today I upload the newest version. So newest version, you don't see deprecated.
Okay.
Side.
Got it. Thank you.
And yeah, I mean, even maybe a few months later, you install KNIME. So some of the module could be deprecated, but I mean, no worries. You can just drag and drop the newer version from your node repository, and it works same as them. Just means you have different versions. That's it.
Okay. One more thing. I wanted to ask. Just now you got that the table of a prediction value of 75%. How did you get that?
Which table you mean?
The one earlier that we were able to tell the statistical values or the 75% thing.
You mean outlier workflow?
I don't remember. I just remember that you asked us. So what was this?
I think he's talking about the score.
The score, yes.
Here? Oh, this one? Okay. So right click. You have two ones, accuracy statistics and confusion matrix. If you click on confusion matrix, you can see if it's actually van, from actual van, how many of them you actually created van. So one of them is van, but you predicted as sub. Or 25 are sub, but you predicted as van. Do you see?
Yeah, I see, but I don't understand what this means.
Okay, the row means the actual value. Column is what you predicted. So row 198 are actually van, and you predicted as van. But one of them was van, but you predicted as sub.
Okay.
Look at second row. 21 was sub, but you predicted as van. 131 was sub, and also you predicted as sub, so you did the correct one. 13 was sub, but you predicted as boss.
Wow, okay. I will have to look at it. Okay.
I mean, if it's confusing, you can reach me later in my office hours, but I hope it makes sense for you.
I will look at it again, and I think I'll come back to you on this.
Yeah, sure, no worries. Okay, if there is no question, that's for today. Thank you very much, and have a great rest of the day.
Thank you.
Thank you.
Thank you.
Professor.
Thank you.
Good, Professor.
Mm.
Good, Professor.